Okay, so the next test here, test 3.2C, okay, under exercise 3.2, question B4, okay, and then 5, all these we'll find on textbook, page 52. So let us start with it. Okay, so before we start, let us remind the three conditions for a pair of linear equations that we have done earlier. Number one is if a1 by a2 is not equal to b1 by b2, then I'm writing in short, okay, then they have unique solution, one way to call it, unique solution, which means they are also called consistent. Okay, let's just write like that, or we call that unique solution means they're consistent. Okay, unique solution or consistent. And the graph, the lines formed by the graphs, I'm writing in short, intersect. Please write along with me, intersect at only one point. That is the first condition. Second one, we can just put it the way we like it. A1 by A2 equal to B1 by B2 equal to C1 by C2. Then they have infinite number of solution. I'm writing in short, infinite solution. That means they have solution, unique solution or infinite solution. They have solution means we call it as consistent. Just like the first case, consistent therefore. And then they intersect at all points and we call that one as coincident. The graphs will be coincident lines. Means the two lines of the graphs will overlap each other, coincident. The third condition is if A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, then no solution. This is the only case when they will have no solution, and no solution means inconsistent. This is the only case. No solution means inconsistent, and the graphs will be, the two lines of the graphs will be parallel. So no solution, inconsistent. Infinite solution, consistent. One solution, unique solution. Solution means consistent. Solution, consistent. No solution means inconsistent. Graph here intersect at one point. Here at all points they intersect, so coincident. A graph parallel. So these three conditions have to be very clear in our mind. Okay, in this exercise or under the chapter linear equations especially. So let us start with question 4. Which of the following pairs of linear equations are consistent or inconsistent? We have to find that first. So whether they are like the first two, which is consistent, or like the third, inconsistent. Like this, consistent, like this, consistent, or like this, inconsistent. We have to first find. Then, if it's consistent, obtain the solution graphically. So let us start with 1. B4 subheading 1. The pair of equations are x plus y is equal to 5. And the next one is x minus y is equal to 8. Sorry. And the other one is 2x plus 2y. 2x plus 2y is equal to 10. So this is equation 1 and 2. Let us name it 1 and this one equation 2. So from equations 1 and 2, let's first find out a1 by a2 means the coefficients of x here, 1 here plus 2 here, so 1 by 2. Then b1 by b2 is the coefficients of y, so here no number, plus 1 by 2. So they are equal, see, 1 by 2, 1 by 2. Then we go and find c1 by c2, which is 5 divided by 10. We have to cancel 5 ones of 5, 5 twos are 10. So that is equal to 1 by 2, right? So therefore we see here very clearly a1 by a2, b1 by b2, c1 by c2, all of them here are 1 by 2, 1 by 2, 1 by 2, same, so they are equal, which means it's exactly like this, number 2. So it is consistent. So you write here, therefore the pair of linear equations, first part of the question, the pair of linear equations are consistent. That's your first answer. Then the question says, so if it's consistent, then obtain the solution graphically by graph. So after you write this on your tuition copy, tear a graph page, okay, and then follow me. Right, we have written up to here, so I'm going to rub it. Then now on your graph paper you do this, or you can continue to do this part also on your tuition copy, not on the graph, sorry. From equation 1, here the coefficient of x is +1, here also 1, so whether you take in terms of x or y, it's same, difficulty level will be the same. So if you take x, that will be equal to 5 minus y. That is your from 1. You got this, shifting this so that taking in terms of x. So make the table because we're going to solve graphically. All this also we can write on our tuition copy, the plain copy itself. Y is on the right side, let's start y first, that's easier now. If you put your 1, then 5 minus 1 is 4. Right, x plus 4. Then if you put your 2, for example, 2, then plus 2, then your minus is there. 5 minus 2 will be 3. And if you put your 3, 5 minus 3 will be 2. So we got table 1 from equation number 1. 3 values of x and y. Then similarly from equation number 2, you form here x, coefficient of x is 2, here also 2. So it's same difficulty, which one you want to take, x or y, up to you. Okay, if you want to take x, also find y also. If you take x, then you're going to get your x is equal to here 10, then if you shift this right side, minus 2y divided by here 2 into x, here 2 is there, so into means if you shift everything, you have to shift right side, so even the 2 shifted, then into becomes divided by 2. So using this, let us form the table 2. So here the table 2 is x values and y values. Let us put your y, let us say 1. Then here okay, let us say put 4. Then here 2 4s are, let me do it here on the rough, you can do 10 minus 2 into y, you have put 4, so divided by 2. Then 2 4s are 8, so 10 minus 8, 2 by 2, so everything cancel means 1. When y value is 4, right, you got x value equal to 1. Then if you put your minus 1, okay, let's just put positive values in, 2 2s are. If you put y equal to 3, let us say y equal to 3, then here this time then x will be equal to 10 minus 2 into y, we have put here 3, so just put the 3 divided by 2. You can write these things on your left. So 10 minus 2 3s are 6 divided by 2. 10 minus 6 is 4 divided by 2, so 2 2s are 4. So you're getting x equal to 2 when y is equal to 3, just as same here. Then if we put y is equal to 5, let us say. Okay, let us just put 5. Then you're going to get x is equal to 10 minus 2 into y is just now put 5 this time divided by 2, as you can see here. 10 minus 2 5s are 10, and here 2, so 10 minus 10 is 0, 0 divided by 2 is 0, so you're going to get x equal to 0. So like that you can take any values, 3 sets. As far as possible, single digits will be easier to plot on the graph. Now, you and your friend will not necessarily get the same values, okay? But if you calculate it correctly, your graphs will come out same. And so the solution is same. So here, we are now ready to plot the graph. So you take the graph paper, and I'm going to need space here. So I'm just going to write table 1 here. Table 1 and 2. So let me just write here table 1 and 2. Okay, table 1. I'm just plotting here. You don't need to write this because I need space. I'm doing it. Okay, 1, 2, 3. So x and y. 4, 3, 2, 1, 2, 3. Then table 2. Here, x and y. 1, 4, 2, 3, 0, 5. Table 2. Then table 2. So now let's just wrap it because I need space here to draw your graph. Now you tear your graph paper. Then draw your x coordinate. Everything is plus, there is no minus. So left side and down we don't need, because down is minus y, left is minus x value. So we don't have any x and y minus. So you can go this right space and up space more because down is minus and there is no minus. So partially plot it towards the left and towards the bottom of your graph paper without any hesitation. So here put arrows, and here also put arrows, and we know this is x dash. This horizontal line is the x-axis. Here y dash, and 0 is the origin. So on the right side is plus, and we have x highest value is 4, 3, 2, 4, 1. So 4 is the highest, so we don't need much also. 1, 2, 3, 4. On your centimeter graph, 4, 3, 2, 1, 0. 5, if you want to go 5, 6, up to you. 1 more extra or 2 more extra, that's up to you. Y is the highest, is 5, so no minus. So just write your 1, 2, 3, 4, 5. That's enough. And there is no minus, but you can put at least 1, minus 1 to show it. Minus 1 on the x-axis, minus 1 on the, or 2, up to you. Plot the first table 4 and 1. So here I have to improvise because I don't have graph paper. But for you it's quite easy. Just do it accurately. 4 and 1. X is 4, y is 1, means y here. This is the y. 1 and 4. So I plot here 4 and 1. So here is the point. This is the 4 and 1, so you can mark it like. Don't make dot like that, okay? I'm having to make it because I need to let you see, but if you do like this, it won't be accurate. So just put a small dot with your pencil. Next is 3 and 2. So 3, that time y is 2. So 3 and 2. 3 on the x and y 2. So here is the point. So I have here 3 and 2. 4 and 2, sorry, 4 and 1. The first point is x value 4, 1. This one is 3, x, y is 2. The next is 2 and 3, so 2, 3. So let's put here, and just let me just make the line to make it easy for me, because for you it's okay, but for me it's easier to make the line once I get the 2 dots. And just do like this. Then next is 2 and 3, so 2 here and 3 here, so 2 and 3 here. So here is the point. 2, x is 2, the time y is 3, so this point 3 and 2. Then second table, 1 and 4, so 1 and y is 4. We find it's on the same line, 1 and then 4. So this is the point having 1 and 4, representing this point 1 and 4. 2 and 3, so sorry, this is 4 and 1, 3 and 2, and this is 2 and 3, sorry. X is 2, y is 3, right, this one. 2 and y, the time is 3. Then here also same, 2 and 3, so this is the common value for these two, so it's the same point. 0 and 5, so x is 0 here, and y is 5 means here. So 5, I'm having to manipulate 5 is here, therefore. So this is the point. When x is 0, here, x is 0, this one. Y value here is y, x is 5. So we got this plot. So the first line we got by taking these 3 points, 1, 2, 3, and this line is the graph of the first equation, AB. So this represents the first equation, this one, x plus y equal to 5, this graph AB. When you took 1 and 4, this one, and 2 and 3, this one, and 0 and 5, these 3 points, is the same straight line passing to the same line again. So this one is the second line CD, representing the graph of the second equation, which is 2x plus 2y is equal to then this CD, and we see that they are overlapping coincident lines. So we can write down now. Graph is drawn. Okay. On plotting just make it short, on plotting, okay, values from tables 1 and 2, we get AB line, the graph, and CD line, the other graph, intersecting at all the points, Therefore, all the points, in other words, in bracket you can write that is coincident, the lines are coincident. Therefore, the pair of linear equations has infinite number of solutions. Equations has infinite number of solutions, means countless number of x and y values, no end to them. Okay, that's the first question. Then let's do the next question. And B, question number B for subheading 2. Here the questions given are x minus y equal to 4, question 1. Then next is 3x minus 3y equal to 16. 3x minus 3y is equal to 16. Question 2. So first job is we have to find whether they are consistent or inconsistent. So a1 by a2 is coefficients of x here, no number, plus 1 here, 3. Then can't cancel that, b1 by b2 is here, no number means 1, and minus, so minus 1 in here by minus 3, so these two cancel, so we get 1 by 3. They are equal, a1 by a2 is equal to b1 by b2. Then only if they're equal, we'll go and find c1 by c2. 4 by 16, so 2 2s are 4, or 4 1s are 4 is going, 4 1s are 4, 4 4s are 16, 1 by 4. So we clearly see that a1 by a2, b1 by b2, and then c1 by c2. A1 by A2 is 1 by 3, B1 by B2 also 1 by 3, so they are equal. These two are equal. But C1 by C2 is 1 by 4, which is not equal to 1 by 3. So we put here not equal to. Then not equal means this condition is exactly the third one, which is inconsistent. So our answer is the pair of linear equations are inconsistent. This is the first part of the question. So if they are inconsistent, we can just stop here. If they are consistent, the question is saying solve by graphical method. So we don't need graph paper here because they are inconsistent. So we go to the next question. In the next class, we'll do that. There are 2 more questions. We'll do that in the next class.